Lovely stuff, what? Very evocative of a time and place, but given that the monks did not have central heating or hot running water, I think I'll pass. The reason for that Gregorian introduction will eventually be made clear in the textual portion of this week's lecture. Like last week, this is a big chunk of stuff. It looks more complicated than it is, but there are some concepts in here you simply have to wrap your heads around. As always, I'm willing to spend a lot of time on the discussion board explaining that which needs explaining. We're now entering an area of statistics where concepts really start getting important. The whole notion of area under the curve is one you have to understand before we start getting into inferential statistics a bit downstream. One of the reasons we're looking at z-scores and percentiles is to give you some practice in thinking about area under the curve. When we get to the idea of statistical significance, you should have a pretty good idea of why we've put in some time with the curve and how it works. I'm also electing to give you correlation as a descriptive technique rather than an inferential one. Earlier in the course, I may have touched briefly on the difference between population or universe and sample. Samples are used for inferential statistics, and one of the major points about sampling is the idea and that all statistics associated with it were developed before computers gave us large-scale data processing capabilities. So a library worker, researcher working in the 1930s who wanted to run some correlations for, say, 722 counties in the Midwest had a huge computational problem on his hands. The amount of time spent simply crunching all the numbers for 722 counties using nothing other than a hand-cranked calculator boggles the mind. Hence, the researcher in question simply pulled a random sample and inferred back to the population from that sample. Comes electronic data processing, and all of a sudden it's a lot easier to crunch numbers for 722 counties. In my public library spreadsheet, I have data for 7,558 libraries and can pull every statistical test known to man on the whole lot in very short order. Sampling is simply not an issue anymore. So while correlational statistics or tests grew out of inferential statistics and sampling, we now clearly have the power to use them as descriptive tools. When you have the computational power to crunch all the numbers, you don't need a sample. Hence, we will take a look at the two major correlational statistics you are apt to run into in the literature and consider them as descriptive tools before moving on to inferential statistics in a bit. There are this week some pretty complex looking formulas. They really are not, as long as you are organized in your approach to them. The key to working with these things by hand, using only the old hand calculator, is being methodically well organized. Since both commonly used spreadsheets and some handheld calculators will crunch one of our correlational statistics, I'm going to skip making you do them by hand. Big sigh of relief, right? The other test, which we'll get into, can be done by hand, or you can look at the tutorial to see how to set it up on the spreadsheet. In either case, check everything. The spreadsheet will do exactly what you tell it to do. So if you get some weird value, be prepared to look at what you have told it to do. Question authority, even if it is Excel. And on that happy note, on to the lecture.